Hello everyone, this is Payal from Electronics and Communication branch, and today I am presenting my PPT on car black box. My contents are C programming, microcontroller, embedded system, and embedded programming, and a project on an embedded system based on a car black box. Let's start the introduction of C programming. First, we see why we are using a C. C is used to reduce the gap between the low and high level language and can be used in a many application level programming. Okay, and then it is very fast in terms of execution time. It is help in understanding the fundamental of computer theory also. There are some features of C which is easy to extend, portable, level language, rich set of built-in operators, and many more. There are keywords in C language. There are basically 32 keywords in C language, in which uh, keywords first type is data type, then modifier, qualifier, loops, jump, decision, storage class, drive, user defined, others. These are types, and and the keywords are char, int, float, double, sign, many more. These all are keywords. How we represent data: basically we represent data in decimal, octal, hexadecimal, binary. In octal, the range is uh, the base of octal is 8, decimal, the base of decimal is 10, hexadecimal 16, binary 2, and uh, and the basic unit of information in computer is a bit, and group of 8 bit is called as byte, uh, and word is a group of 2 bytes. All these are the way in which we represent data. And then see how then see data types. There are many data types. For example, signed char, unsigned char, short signed int, short unsigned int, long, float, double. All these are data types. Next, we see conditional construct, means conditional statement. There are there we see if else conditional statements, which in if else there are if else, if nested if, all. And here we see the syntax, how we write these conditions. Next, there is a operator in which we there are arithmetic operator, relational operator, logical operator, bitwise, assignment, ternary. All these are operators. Here is an example of arithmetic operators, example of logical operator, example of bitwise and relational operator, and this is example of increment and decrement operator, ternary operator, example of assignment operator. Next, we see the array. Array is a sequence of objects which are same data types, in which we generally see it as a set of memory location, in which we locate same data types of values. And in array, in array, uh, here is a lower address corresponding to the first element, and the highest address is corresponding to the last element. Next, we see declaration and initialization of array. Declaring array. To declare an array is in C, a programmer specify the type of a element and the number of elements required by a array as a type array. This is called as a single dimensional array. And next is initializing array. We can initialize an array in either one by one or using single statement as follow. Here is an example: double balance in square bracket we wrote 10, in which we declare 1, 0.5, 3.08. All these values under braces cannot be larger than the number of element declared in a square bracket. Next, accessing array element. An element is accessed by indexing the array name. This is done by placing the index of the element within the square brackets after the name of the array. The above statement will take 10th element from the array and assign the value to the salary value. This is an example of array. Next, we see pointer. Pointers store the address of a variable or a memory. They are declared as data type uh, star variable name. And feature, what is the feature of a pointer? Feature of a pointer is used to file handling and used to allocate memory dynamically. Next, this is how we represent pointer in C language. Next, referencing of pointer, making a pointer variable to a point other variable by providing address of that variable to the pointer is known as referencing of pointer. It is also known as initializing of pointer. This is how we initialize the pointer. Here ptr got address of a variable a, so the pointer ptr now pointing a variable a. Next, storage. All the computer do not store the byte that comprise a multi-byte value in a same order. Next, we see microcontroller, which we learn in this internship. First, we see controllers and its peripherals, then choosing a microcontroller. What is microcontroller? First question come in our mind is, what is microcontroller? Microcontroller is a small computer on a single multi-oxide semiconductor integrated chip. It contains one or more CPUs along with the memory and programmable input-output peripherals. A microcontroller can be programmed to do a specific task based on its instruction set and capabilities. Sometimes solutions are very complex. Circuits also become very complex if we try to solve it only using hardware. How does it work? Microcontroller process data given to its input pin using its CPU and give output through output pins. It execute or driven by a synchronous sequential logic circuit, which are logical circuit whose output not only depend on the present input but also on the past inputs. Elements and application of microcontroller. First we see elements. um, First element: CPU, RAM, ROM, input output port, clock, counter, timer, I2C, analog to digital converter. All these are elements of microcontroller. Now we see application. Let's see, in our house we can see TV, TV remote, set-top box, micro oven, washing machine, air conditioner. All these are using microcontroller. Let's see what is the difference between microcontroller and microprocessor. Microprocessor act as a heart of a computer system, but microcontroller is act as a heart of a embedded system. In microprocessor, it is a process which memory and IO input output components are connected externally, but in microcontroller it is controlling device in which memory and our input output components present internally. It cannot microprocessor is having zero flag state, and microcontroller have no zero flag state. Next we see choosing a microcontroller. The key factor help in choosing a microcontrollers are power efficiency, temperature tolerance, processing power, hardware architecture, memory, hardware interference, hardware architecture, software architecture, cost, and securities. All these are factors are considered while choosing a microcontroller. Next we see embedded system. What what is embedded system? Embedded system is any combination of hardware and software which are intended to do a specific task is called as a embedded system. It is a combination of computer process, computer memory, input output peripheral devices that has dedicated functional functions within a large mechanical and electronic system. It is embedded as a part of a complete device, often including a electrical or electronics hardware. Because an embedded system typically control physical operation of a machine, it is embedded within, and if often has a real-time computing concentrate. All these are the example of embedded system. Now, categories. Based on a functional requirement, embedded systems are categorized as real-time embedded system, standalone embedded system, networked embedded system, and mobile embedded system. First, let's see. Next, we see components of a embedded system. Embedded system has three components. It has hardware, it has application software, and it has real-time operating system. A real-time operating system is defined as a way of a system work. It is a set of a rules during execution of application program. A small scale embedded system is not have RTOS. This is a architecture. So we can define a embedded system as a microcontroller based, software driven, reliable real time control system. Now, requirements. Functional requirements. First, input functional means what we required for functioning. Uh, First is input, output, processing. Next, non-functional requirement: reliability, cost effectiveness, low power consumptions, effective uses of memory. What is the challenges with embedded system? Effective input output, embedding on OS, testing and debugging, code optimization, how much hardware needed, how big the CPU and memory required, how do we meet our deadlines, faster hardwares, how do we minimize power, turn off unnecessary logic, reduce memory excess. Now, trend in development: processor, memory, operating system, programming language, more computing power and new architectures, low power consumption, more security, more robustness, connectivity, and more local autonomy. Common design metrics are time to prototypes, power, size, NRE, performance and correctness, flexibility, maintenance, unit cost, safety, time to market. Real-time aspects are: real-time embedded system is particularly version of embedded system that work on the basis of real-time computing representation by dedicated type of operating system, RTOS. There are hard real time, frame real time, soft real time. In hard real time should meet its deadline. In frame real time, similar to hard real time, soft real time have can have tolerance in meeting its deadlines. Next, embedded programming. Embedded programming is known as embedded software development or embedded system programming. It is a specific type of programming that supports the creation of consumer facing or business facing device that does not operate on traditional operating system the way that full scale laptop, computer and mobile device do. Now come to our project which we done in this internship is car black box, in which in car black box first we see the introduction part, then block diagram, working, tools, simulation, application and advantage and disadvantage. First we see introduction of car black box. Well, what is black box? A black box is either physically installed in a car or downloaded as a smartphone app. It is linked to a GPS device that measure and record the vehicle speed, location, distance traveled, driving frequency, and the time of the car is in motion. It is monitor it is monitor events like speed, accident, location of the car. They are called as a event data recorder. This is how a car black box look like. Next, this is a block diagram of car black box, in which this is a keypad controller, ima- RTC, audio coder, trans receiver, lots of thing in this. This is processor. Next, what are the peripherals and hardware required in a car black box? These are LCD display, 6 switches, potentiometer, EEPROM ROM, microcontroller, RTC. Next, we are using microcontroller which is PIC 16 F877A. It is a 40 pin microcontroller. While doing this project, we required tools which is MP Lab XID, which is a development environment, and MP Lab XC8 compiler, cross compiler, and Pixim Lab simulator. These all are the tools which are required to simulate a car black box. M, MP Lab XIDE is which are being uses for embedded system development with PIC microcontroller. Also product from microchip which is so powerful and versatile. It is used to create a new project and handle to write a assembly language program for a interface. We can create the new project, write a project name and write a code in a MPLAB XIDE. This is in this we write introduction. uh, this is the architecture of PIC 16 F877A. This is a Pixim simulator. Let me wait. In Pixing Lab, we have LEDs, digital keypad, interrupt, timer, clock IO, SSD, mm, CLCD, matrix keypad, and analog input. First, we describe LED. LED is a simplest device used in most of the embedded application as a feedback. It works just like a diode, low energy consumption, longer life, small in size, faster switching. All these are the advantage of LEDs. This is LEDs on a circuit. This is how LEDs look like in a circuit board. This is LCD. LCD is used to display the output. This is LCD circuit look like on a board. digital keypad provide a simple and cheap interface, come in different shape and size, many more. This is how it look on a circuit board. Mm, Tactile switch, this is a tactile switch. Matrix keypad. Interrupt. Next we come to the interrupt. Interrupt is a communication process set up in a microprocessor or a microcontroller in which the internal and external device request the microprocess to stop the process, attend the request, and go back to the processing where it was interrupted. There are two types of interrupt: internal and external. Sorry, internal sorry, interrupt, a hardware interrupt and software interrupt. In hardware interrupt, there are more classification: markable interrupt and non-markable interrupt. This is how we write a program for a LED. This is the output look like keypad matrix. This is all the programs we write to perform write a program to simulate the car black box. This is all. Thank you for giving the opportunity to learn a car black box embedded programming. Thank you so much. And this is how simulator look like. Thank you.